Hello, lovely students. Welcome to my lesson on repetition. Today we're going to be looking at the coding challenge 1 and possible solutions. I'm also going to be emphasizing the use of trace tables using for loops. Let's have a look at it. I'm not going to be presenting the solutions in the order that was given on the questions. I want to start first with question 1.3, where you had to determine if a number is a prime number. So in this particular question, you are asked to generate a random integer between 5 and 50, both inclusive. And then you had to determine and display the factors of the random number generated. Remember, a factor is a number that is divisible by another number and it has no remainder. And a prime number is a number that has two factors, the value 1 and the number itself. So let's have a look at the segment of a program, and we're going to be doing a trace table. Trace tables are a very valuable debugging mechanism or tool. It also helps you to nurture your brain when you are programming, to do a mental trace of your ideas, your thoughts, and the coding. And if you can mentally trace something and put it into an algorithm, writing the coding becomes simplified. So let's have a look at the segment of a program and the trace table. So I'm going to create a counting variable to count the factor. So I created and initialized iCountFactors, and I initialized it to 0. So on my trace table, iCountFactors is initialized to a value 0. I'm then generating a random number between 5 and 50, both inclusive. Now when you're using random, the function from the math unit, it's the upper limit, which is 50, minus the lower limit, which is 5, and you add 1 to that. And it is always plus the lower limit value. So I'm going to generate a random number, and I'm going to assume that the random number generated was 7. I then come into my loop. For I, which is my loop counter, and you must declare I, starts off at 1 and ends at the maximum value, which is the value of the random number generated. So when I starts off at 1, my value of I starts off at 1 on my trace table. And then remember, when you're working with a for loop, you then check if 1 is less than or equal to the random number. So I'm physically checking, is 1 less than or equal to 7? If the condition is true, I come inside and I execute statements inside the loop. So I'm checking in my if condition, is the random number modulus I? Remember, mod is the operator that gives you the remainder. Is the random number modulus I equals 0? So I am checking the random number is 7. 7 mod 1. Is the remainder 0? So you're asking yourself, 1 can go into 7 times. Yes, my remainder is 0. So if my remainder is 0, this condition evaluates to true. So on my trace table, I will put the value true. Remember, a Boolean condition evaluates to true or false. If the condition is true, I execute statements inside the if. So the statements inside the if, remember I've got compound statements inside the if. I need a begin and an end. So So the first statement is I'm displaying the value of I, and the value of I at the moment is 1. So I am saying if the number generated, which is 7 mod 1 equals 0, if the remainder is 0, it means that I is a factor of the number. So it just means that 1 is a factor of 7. And when I find the first factor, I need to display the factor. Display the value of I. And I'm going to display 1. Now that I've found a factor, I need to increment my count factor because I found the first factor. Count factors now takes on the value 1. It's incremented by 1. Note I'm using the inc procedure. It means that increment I count factors by 1. I'm in a loop. So I'm going to increment my loop counter variable now, which is I, and I now goes to 2. So I go up, I is now 2. I now check my condition, that is true. I come in here and I check. Is the random number mod 2? Is 7 mod 2 equal to 0? False. My remainder is not 0. So if my remainder is not 0, it means that 2 is not a factor of 7. If it is not a factor of 7 and this condition is false, I do not execute statements inside my if. I hit the end of my if statement and I now becomes 3. I then check my condition in my for loop, it's true. I come into my if statement and I check if 7 mod 3 equals 0. False. If this condition is false, I come in and if this condition is false, I do not execute statements in the if. I hit the end and I now becomes 4. I check my condition. If that is true, I come in here. I'm now checking if 7 mod 4 equals 0. False. I do not execute statements. At the end, I now becomes 5. I check my condition. That's true. I now check if 7 mod 5 equals 0. False. If that is false, I do not execute. I now becomes 6. I go back up, check my condition. Remember, this is an iteration loop. On every iteration, it increments by 1. So hence, I is going 1, 2, 3, 4, 5, 6. So I check the condition, 6 is less than or equal to the random number, which is 7, true. I then come into my into my if statement, and I'm checking if 7 mod 6 equals 0. False. If it's false, nothing happens. I hit the end and I now become 7. Check my condition in my for, it's true. I come into my if statement and I'm now checking if 7 mod I equals 0, and that evaluates to true. Okay, 7 mod 7, my remainder is 0. So if my remainder is 0, then my condition evaluates to true. I now display the value of I, which is 7. I now found another factor of 7, which is the number itself. What happens to my I count factors? It has to be incremented. So I count factors now changes to 2. I have now found 2 factors. Remember, I've come to an end of my loop. I hit the end and I goes now to the next number and the loop terminates. I'm now out of the loop and I'm checking. If I count factors is equal to 2, I'm checking this variable. Is this I count factors equal to 2? True. If that condition is true, if I count factors equal to 2, true, I then display that the random number generated is a prime number. So it's going to display 7 is a prime number under the display section. It was just, the column was small, so I couldn't really display it, but it will display on a rich edit that the random number is a prime number. Trace tables are very valuable, kids. I would like you, as a next example, to do a trace table on your own. And instead of generating a random number of 7, possibly try if the number is 9. If the random number generated is 9, I would like you to do a trace table on your own and trace through the segment of the program to see what happens when a number is not a prime number. Let's have a look at the Delphi program for this question. So let's look at the Delphi part for prime numbers question 1.3. Okay, so I created a variable to generate the random number. I is my loop counter and the variable to count factors. I initialized count factor to 0. I generated a random number using random. I ran my for loop from 1 to the random number. I checked if the random number mod I equals 0. And if the condition is true, I displayed the value of I because I is a factor, and then I incremented my counting variable. The loop is going to execute from 1 to the random number. So if the random number generated was 7, the loop is going to start off at 1 and it's going to check is 1 a factor, then it's going to go to 2, is 2 a factor, then it's going to go to 3, is 3 a factor, is 4 a factor, 5 a factor, 6 a factor, and 7 a factor. So it's checking each number from 1 to the random number if each value is a factor of the number. At the end of the loop, it's going to count how many factors, and out of the for loop, if the number of factors is equal to 2, it's then going to display the random number is a prime number. Okay, so let's run this program. I've done detailed explanation on the trace table, so we're just merely stepping through the code. Let's have a look at how it works. Okay, so question 1.3. Display factors and check if it is a prime number. Remember, it's generating one random number, and then it's checking the factors of the number and it's displaying it. Okay, so let's check when it's going to be a prime number. It only has 2 factors. No, not a prime number. Too many factors, too many factors, too many factors. Okay, let's check again. Okay, so 11 has 2 factors, 1 and the number itself. So 11 is a prime number. Let's take a look at question 1.4. Okay, so let's take a look at question 1.4, count even numbers. In this example, you had to generate 10 random numbers between 1 and 50, both inclusive, and you had to count how many even numbers that were generated. So for the purpose of this exercise, so I can do a trace table, I have sample output of 10 random numbers generated between 1 and 50. I created a variable called iCountEven that's going to keep track of the number of even numbers, and I initialized it to 0. I'm running my loop from 1 to 10 because I want to generate 10 numbers. Remember, a for loop performs fixed repetition. It's the number of repetitions are known. I'm then generating a random number, and note in this example I'm using random range. Random range is called with 2 parameters, the start value, and the second parameter is your end index plus 1. I'm then checking if the random number mod 2 equals 0. This is the formula to test if a number entered is an even number. If the number entered mod 2, mod gives you the remainder. If the remainder of this is equal to 0, then this condition evaluates to true, and then all I'm doing is incrementing my counter. Note, instead of using inc, the procedure, I'm using an accumulation technique, and I'm saying I count even is assigned whatever the current value of I count is, plus 1. So the loop is going to execute 10 times, and out of the loop, I'm going to display the total number of even numbers generated, which will be the value stored in I count even. So let's do a trace and step through each line of code in the segment. So my first variable I count even is initialized to 0. So on my trace table, I count even initialized to 0. I come into my for loop and I takes on the value 1. I test my condition, that's true. I generate the first random number, which is 7. I check if 7 mod 2 equals 0, false. If the condition evaluates to false, I do not execute statements in the if. My loop counter now increments by 1. I now becomes 2. Test the condition, true. I generate the next even number, 9. I check in my if statement if 9 mod 2 equals 0, false. Nothing happens. Go back up and I is now 3. Test the condition, true. Generate the next random number. I now check if 10 mod 2 equals 0, true. If the condition evaluates to true, it means that the random number generated is an even number. I now need to increment my counter variable value. I count even is assigned the current value of I count, which is 0 plus 1, because I found the first even number, and that value now changes to 1. I hit the end and I go back up and the value of I is now 4. Check the condition, true. Generate the next random number, 18. I now check if 18 mod 2 equals 0, true. Increment the counter, 2. I now found the next even number. Remember, I'm in a loop. The loop has to terminate. It has to quit. And it only quit at the end of the loop. But I'm still on 4. Now goes to 5. Check my condition, true. Generate the next number, 24. I'm now checking if 24 mod 2 equals 0, true. What happens now? I count even has a current value which is 2, and now found the next even number. My I count even needs to be incremented by 1 plus 1. I count now even. I count even has the value 3. I increment my loop counter, goes to 6. I now generate the next random number, 6. I now check if the random number mod 2 equals 0, true. Increment my counter now goes to 4. Increment my I loop goes to 7. Check the condition in the loop. Is it true? Yes. 7 is less than or equal to 10. I then generate the next random number, 3. Is 3 mod 2 equals 0? False. Nothing happens. Increment I. I now goes to 8. Remember, I is my loop counter. Generate the next random number. The random number generated is 5. I now check if 5 mod 2 equals 0. False. Nothing happens. Go back up and I is now 9. Check the condition. Condition evaluates to true. Generate the next random number, 11. I now check, is 11 mod 2 equals 0? False. Nothing happens. Go back up and I is now 10. Check the condition. Condition is true. Generate the next random number, 44. I'm now checking, is 44 mod 2 equals 0? True. What happens to I count in this part? I count even takes on the current value, which is 4, and you add 1. I count even is now 5. I hit the end and I now becomes 11 and the loop terminates. Out of the loop, I execute statements out of the begin and end of my for loop. I now display on a rich edit total even numbers generated is whatever is stored in the variable count, I count even, and it will display the total is 5. I didn't have enough space to put in the entire string literal, but this is a lovely example of a trace table. I would like you to take another set of 10 numbers and do this trace table on your own to understand how a trace table works. Let's have a look at the Delphi program. Okay, so I needed to check 10 numbers. I needed to enter 10 integer numbers. So my loop is starting at 1 and ending at 10. I needed to generate a random number, and note I'm using random range. And I'm generating a number between 1 and 50, both inclusive. And using the formula, the random number mod 2 equals 0, I'm able to check if a number is an even number. And each time I find an even number, I need to increment my counter. At the end of the loop, I can display the total number of even numbers generated is the value stored in the variable I count even. Also remember that you need to declare variables, the random number, I for my loop counter, and I count even to keep track of the number of even numbers. And do not forget that you need to initialize I count even to 0 before the for loop. There's many ways you can increment your counter. An accumulation technique, where you can say I count even, assignment statement, I count even plus 1, or you could use inc, I count even, or you could use inc, I count even, incremented by a value. So I could say increment I count by 1, or I can increment I count by 2. So I could use inc in that way too. Let's run this program and see how it works. Okay, so question 1.4. I'm generating 10 even numbers. I'm generating 10 random numbers, and I'm determining the number of even numbers. Let's have a look at it. So total even numbers generated is 5 out of the 10 numbers that were generated. And I didn't display the 10 numbers. The question only asked to display how many even numbers were generated. Let's have a look at question 1.1 and question 1.2, what you had to do there. So in question 1.1, all we had to do was to take the panel and change the color to lime, change the font property of the panel. The font color must change to red, the font size must change to 20, and the panel caption must read Coding Challenge 1. We normally teach this at the beginning of the year, where you do it on the object inspector, on the properties. but we also teach it using coding, and it comes out in every exam where you have to code the properties. Let's run it and see how it works. Okay, display heading, and it displays panel changed to green, the font size changed, and the font color to red. Let's have a look at question 1.2. So question 1.2, you have to find the volume. Okay, so I've created a variable for the radius, a variable for the height. They're of data type real. You could declare it of data type double, and one for the liquid volume to calculate the amount of liquid. Remember, the question asked you to calculate the volume of liquid required to fill the can. So this is going to calculate the volume of liquid required to fill the can using the formula that was given. Okay, so I'm getting the radius from a t-edit. I'm extracting the height also from a t-edit. Note that I'm converting from string to float. I'm then calculating the volume of liquid to fill the can. Pi, which is 22/7. You could use pi, which is a function of the math unit, or you could use 22/7. I'm multiplying that by the radius squared. You could say radius times radius, or you could use square, the function of the math unit. Multiplying that by the height minus 1. Remember, I do not want to take the height to the top of the can. I only want the volume of liquid, the part where the liquid is only filled. And then at the end, I'm displaying the volume of liquid to fill the can to 1 decimal space. So let's go and have a look at it. Remember, using float to string f, the variable that you want to format, ff fixed, 5 is your field width, and 1 is 1 decimal place. Let's run it and have a look at how it works. Okay, question 1.2, let's enter our height. Let's enter the radius and calculate the volume, and it's 19.9. Thank you, learners, for listening. I've now come to an end of the Coding Challenge 1 using loops. I hope you thoroughly enjoyed this activity, and I hope you've learned a lot in terms of the discussion of the solution using trace tables. Stay inspired, stay motivated, and follow me on my next video.